Okay, so for this question, I'm gonna work through this as if I'm solving it from scratch. This is how you should do this. So you kind of want to think, read through the givens, right? So BFCE, that's just saying that that's a straight line. GF is congruent to GC, so mark that up. GF is congruent to GC. And then we have AB is perpendicular to BE, so then we have to write this out, but AB perpendicular to BE, this is a right angle. And then DE is EB, this is a right angle. Um, okay, so what I see here already are two congruent triangles. Or sorry, not congruent, but two triangles inside here. This inside here, right? To me, whenever you see this, like two sides are congruent, and you see this like mini triangle here, think isosceles, right? Isosceles theorem. Um, so since these two sides are congruent, the angles opposite must be congruent. So we have that. Now, if I redraw this, and this is something you should probably do, is every time you have nested triangles, like a triangle inside of a triangle, just redraw them. So just on the side, like this, and then it's easier to follow. So yeah, you do this, and then we're gonna mark it up just the same. So this is right angle, this is a right angle. Based on that isosceles triangle, these two are congruent. So yeah, we have two angles, similarity, right? So this is kind of like the first thing you want to do. You want to have a strategy going into this. Okay, so since it says prove something this times this equals this times this, you should the pattern is this. You're gonna use probably angle similarity, right? This is gonna um, be like 90% of the questions. You're gonna use angle to prove similarity. So yeah, you'll say something like um, ABC is similar to DEF, right? And then after this, you're gonna do something like um, this divided by something. So AB, this is this. Um, let's see, EF is this, and then DE is this. So I'm gonna jump to BC. So BC is this, right? And then DE is this. So basically, after angle, the next thing you're gonna probably do is show that these two are in proportion, right? So this is gonna be AB over, and you kind of want to work backwards from what you want to prove, right? So since they have this, you kind of want to match it up. So AB over BC is equal to, or is in proportion to, DE over EF, right? If we just divide both sides, right? And then the reason for this would be CSSTP. I don't know what your teacher uses, but like the short form is CSSTP. This stands for corresponding sides um, of similar triangles are in proportion. Corresponding, I'll type this, but you'll see sides of triangles are in proportion. Um, okay, and then we're not done yet. So yeah, sometimes they ask for this like this fraction equals this fraction, but sometimes they ask for this something times this. So once you have two triangles are similar, and then you have triangles sides are in proportion, the next step is going to be what they're asking you. Okay, so yeah, as long as you can get two angles, this is a pretty free proof. If you can show two angles inside of these triangles, automatically you have ABC is similar to DEF, and then you just have to pick, you have to work backwards and pick what divided by what equals what divided by what using CSSTP. And then final step, you're gonna write out what they ask you to prove, and the reason for this is gonna be um, product of the means equals product of extremes. Yeah. Okay, so this is a strategy. Okay, now I'm gonna actually type this all up. You kind of want to start off with this plan. Matter of fact, I would have just done this, drawn out the two triangles, and then I would have just jumped into typing it or like writing it. So, but yeah, this is like a mini explanation. This is pretty much all similarity proofs. This is how it works. Yeah. First, prove them two triangles similar, then put them in proportions, and then if you have to, multiply them. Okay, so let's get into it. So for this one, um, Yeah, whenever I see the perpendicular symbol, right, there's two things you gotta do, like automatically. So we can say AB, um, sorry, angle. We can say, here, maybe I shouldn't have wrote that first. So I try to emphasize this. Whenever you see perpendicular, automatically you should say that angle is a right angle. And then you're gonna have two of these, like two angles are right angles, like this one and this one, right? And then after this is always right angles are congruent. Okay, you have to have these steps. This works for altitude, this works for perpendicular lines. Yeah, whenever you see those words, first you want to say this angle ABC is a right angle. Also, angle, oops, um, angle DEF is a right angle. I don't know what your teacher uses, but you can say perpendicular lines form right angles. And same thing for 6. Just do this. And then we can say angle ABC is congruent to angle DEF because all right angles are congruent. And then we can say, yeah, this little triangle is congruent to this, yeah, the isosceles triangle theorem. So then we can say angle GFC is congruent to angle GCF, and this is sides opposite congruent angles opposite congruent sides are congruent. Angles opposite congruent sides are congruent. Okay, and then so now we have the angles. We have two angles, so now we can say triangle ABC. ABC is similar to triangle DEF. Remember, the order matters, so I'm just double checking. Yeah, A to B to C is similar to D to E to F. The middle letter is a right angle. Okay, and this is angle. You say postulate or whatever. And then we can say, whoops, 6, 7, 6 twice. That's okay, no big deal. And then we can say 6, 9. And then we can say, pretty much, I already wrote it. So AB over BC is in proportion to DE over EF, and this is because of yeah, I'll just write it. Corresponding sides of similar triangles are in proportion. This is CSSTP, and then finally we have AB times EF is equal to DE times BC. And this is because product of the means is equal to the product of the extremes. Okay.